So from previous year, some changes have been made in free response question. From 5, now it is 4. So you have to do only 4 questions, and so it would have mathematical routines. So it focuses how you drive your equation. So any situation would be given, and they will ask you the derivation. So mainly it is derivation. So mathematical part is it focus on the algebraic part and the numerical, and translation between representation. So when you drive something, so how can you use a graph? So like how can you explain this? Okay, how can you interpret the graph? Like for example, in the questions, graph is given to you and a slope is asked, so you should know what is line equation, you should know what is parabola equation, you should know how the slope we can find from the graph. So all these are in used in this translation between representation. So how you translate them? Okay, experimental design. So sometimes question is asked that this is the case, we have this setup, we have this instrument, that instrument, everything is would be given, and you are asked to design a experiment around a hypothesis. So a question would be given that we want to find the k of the spring constant, we want to find the spring constant, so design an experiment around that. So these type of questions are asked in FRQs. Okay, you have to design the experiment, like how we can find the result, how we can find the desired quantity. And quantitative translation, so combines conceptual reasoning with quantitative analysis to analyze the physical formula. So sometimes it can be asked like why the I moment of inertia of a spring, of a disc and of a ring is different from each other. So you know the formula, that is fine. You know that I is equal to mr square. Okay, but how it is, like how you interpret it. So for disk, the mass is evenly distributed, and whereas for the hoop, the mass is at around the corner. So that's why it has greater I. So these things, like you know the formula, but you should know what you understand from this formula that they want to know. So let's practice some of the questions, some of the FRQs, through which you understand what type of questions are asked in the exam. So first is based on the oscillations. A cart on the horizontal surface is attached to the spring. Okay. The other end of the spring is attached to the wall. The cart is initially held at rest. So initially it is at rest at this point, as shown in this figure. And okay, it is oscillating between plus and minus L. So figure 2 shows the kinetic energy of the cart spring system as a function of system potential energy. So on the on the y-axis we have kinetic energy, and on the x-axis we have potential energy. So friction forces are negligible. So we have to on the graph K versus U is shown, x and y doesn't. Briefly explain why this is true using the physics principle. So we know from this graph, if you remember that if you remember, this was a graph. This type of graph you must have seen, right? So this graph is of kinetic energy. This is potential energy. Okay. See this graph. This is energy versus spring distance. Okay, when you are stretching. So this kinetic energy is zero. Like velocity is zero at this point. At when the amplitude is maximum, displacement is there, amplitude is there. So V is zero at this point. So the kinetic energy is zero at this point, right? But the maximum stretching is there, so that's why potential energy is maximum. And at any point, if you see, if you see, it's just the sum of kinetic and potential is always constant. As you can see, this is the line for total energy, right? And when you reach at this point, when x is equal to 0, so at this point V is maximum, right? And this, the force is 0, means the stretching is 0, so the potential energy is 0 and kinetic energy is maximum at this point, right? So this is how variation between potential and kinetic energy, but the total energy of this spring block system, it would remain constant. So in this, how we prove that this is correct? So for that, at any point, at any point, kinetic plus u should be constant. So let's check at this point. What is the kinetic plus potential? So kinetic is 4, potential is 0. So this is 4. At this point, can you tell me what is kinetic energy? 3 and potential is
3 and
1.
then 10.
So it's 4. At this point, can you tell me kinetic and potential?
They're 2 and 2.
So it's 4, right? Yeah. At this point,
But 1 of kinetic and then 3 of potential.
yes. So it is 4. So it is 4. So at every point, it is kinetic plus potential. It is constant, which is equal to 4. Let's come to second part, which says when the cart is at plus L and momentarily at rest, a block is dropped onto the cart as shown in this figure. The block sticks to the cart and the block cart's spring system continues to oscillate between minus L and plus L. The masses of the cart and the block are m0 and 3 m0 respectively. So we have to find the frequency. Frequency in the first case f1, frequency in the second case is f2. We have to calculate the ratio. What is frequency? 1 upon t. And if you know, t is equal to 2 pi root of m upon k. K is the spring constant. Yes. So from this, I can say that the frequency is equal to 1 upon 2 pi root m over root k. So something like this. So I can say that the frequency is proportional to root of k over m. K is the spring constant. It is same for every spring. Like for a given spring, k would be constant. So I can write that the frequency is proportional to the root of mass. For the first case, what was the mass? Only m0.
Yeah.
And in the second case, what is the mass?
3m.
No, total.
Oh, would be 4.
4 m0. So that's why we have to find f2 upon f1. So it would be root 4 m0 upon root m0 in the numerator. So when you solve it, it would be 1 upon 2. Is this clear?
Yeah, that makes sense.
Now let's come to the another part which says a dashed line in figure 4 shows kinetic energy K versus potential energy of the block cart's spring system. Okay, block is dropped onto the cart. This graph is identical to the graph shown in this figure 2. Briefly explain why the two graphs must be same using the physics principle. So this graph is made for this second case. Second case means this case. And this also, when the only cart was there, this was the graph. So why there is no change in this graph and this graph? As you can see, it is 4, 4, 4, everything. So why this graph is same?
I don't know.
So energy is what? Energy is what? A form of work. So any work done on the system or done by the system, in this case, any work done by the system or on the system? No, right? A mass is added, but that is not work done. So work done is what? Force into displacement. So no extra force is given to the system or we have taken any force work from the system. So that's why this 4 value and this 4 is the graph is same. Second part, after the block is dropped onto the cart, consider a system that consists only of cart and spring. So this potential energy is what? Block, cart, spring system. The block, cart and spring system. And in this same graph, now it is saying that consider a system consists only of cart and spring after the block is dropped on the cart. Don't confuse yourself with the first scenario. No, I am just talking about this scenario only. After dropping the block,
Mhm.
See, after dropping the block onto the cart, consider a system. Now the system would be only cart and the spring. In figure 4, sketch a solid line that shows the kinetic energy of the system that consists of cart and the spring, but not the block after it is dropped onto the cart. So this is a spring and this is your cart, okay, and this is your block, and we don't have to include block now. Talk about the potential energy first. So what is the potential energy of this block and cart? What is potential energy?
Half kx squared.
So half kx squared. This x is the same when we consider the block and cart, and when we consider only block, this x would be same in both the scenarios. Okay, so this is the point. Now let's talk about the kinetic energy. So when this system is at x is equal to 0, it would have V max, okay, and if you see half mv square, when so V max is the same, velocity would be same, achieved by the cart and with the system when the cart and block would be there. But the mass, now we have to consider the system is our only cart. So I have to write the kinetic energy compared to this, because it was previously it was half 4m naught V max square, and
Mhm.
now the mass is only the cart's mass, which is m naught. So the kinetic energy would be,
1/4.
yeah. So 1/4 upon 1/4, so it would be 1.
One.
Okay. So we have to draw a solid line, draw a straight line. Okay. So from this, it is clear to you that graphs questions can be asked. You have to do somewhere the derivations like this. Derivation, show
Mhm.
the derivation, and you have to interpret the graph as well. Thanks for watching. If you like the video, then please like it and subscribe the channel. We will bring more problems along with the solution. So if you have any query, then you can WhatsApp me. If you want a private tuition from me, then you can scan this or send me an email on forcetra.physicss@gmail.com. See you in the next video.